out there are billions of stars, okay, tens of billions of planets in our Milky Way galaxy with conditions similar to those on Earth based on the latest statistics that we know about planets around stars. And so I would say it's very arrogant of us to think that we are unique and special and the only ones.
Hello. Today I chat with Avi Loeb, who is this amazing astronomer at Harvard who is really looking for these extraterrestrial objects. And he has found he's kind of controversial because he is, looking at the world and saying, "Oh my God, we're just so myopic and only looking at Earth. And what we should really do is be looking out into space and seeing what we can learn from other intelligent life out there." And so that's kind of a scary proposition, but he's pretty excited by it. And so we chat about a variety of things in that space, three main things. One is, first, how he thinks that the primary way we're going to interact with these objects is through, that they'll be kind of artificial. They're not going to be like, if UFOs and things like that, they're not going to be biological. It's tough to survive in space for millions of years like that. They're going to be more like these little probes that have kind of intelligent life, kind of GPT-1000 or whatever inside them. And then second, we chat about this project that he's doing called Galileo Project to find UFOs. And it's a pretty massive project, dozens or hundreds of people in there, really, building observatories, traveling to Papua New Guinea because this, extraterrestrial object, the first one in our solar system, it fell into the ocean there in 2017. So he's going to go check that out. Who knows what he's going to find? And so we chat about that project and like his process for finding stuff in space. And then third, we kind of get into the philosophical stuff as well, which is like, why he's not scared of interacting with aliens, and also this concept of aliens and God and how they may relate. So it's a good conversation, and it'll really teach you about how, we're probably not alone, and how we can go out there and start finding these artifacts and gadgets and intelligence that will be able to help us as a species learn and grow. So with that, I hope you enjoy this episode with Avi. Yeah, it's a nice special one. Okay, thanks. Hello, Rhys Pieces. I'm Rhys, the founder of Root, and welcome to the Rhys Show. I believe we can make a great Earth by 2100, an Earth that we're proud of. And we're here to work backwards from that good future. And so this podcast interviews experts to empower you, the listener, a curious, serious frontier person with both frameworks and agency to build that better future. And today, I'm excited to chat with Avi Loeb. Avi is a professor of astronomy at Harvard University and is the author of several great books on these subjects. Extraterrestrial is one of his existing books, bestseller in many languages, etc., etc. And then Interstellar is an upcoming book. Avi, thanks for being on the show and welcome.
Thanks for having me.
Yeah, we're excited to dive in. And Avi and I are doing this kind of jazzy style. He's got a busy next couple of weeks, and so we're just like, let's do it this morning. And so we're kind of here.
May I comment on your first remark?
Yes, of course.
Actually, in my mind, the most important development recently is artificial intelligence, the GPT-4 that will grow to have more connections than the human brain. And the question is, how do we indeed, by the year 2100, how do we guarantee a better future? And one of the ways to do that is, instead of training it on all the trash that can be found on the internet, which we currently do, and then we complain about it, it's just like looking at the mirror and complaining about the image that we see. Obviously, humans do not do everything to our satisfaction. There is a lot of negativity on the internet. So instead of training it on whatever is out there, including books and so forth, we might want to train it on the kind of future that we want to accomplish. And in that sense, it's just like the education system of kids. The government allows certain types of books in schools just to make the future better than the past. And here we can not only train it on positivity, but also train it on text that we craft along the lines of what we want to see in the future that does not exist yet, that did not exist in the past, so we can have a better future than our past.
Yeah, I love that. I think it's a great point, which is that you and I as kids, we were socialized. We were by our parents and also institutionalized by the states around us. You, Israel, is that right? You were born in
I was
Israel?
born.
Yeah, yeah, and me
My,
in the
my
U.S.
wife,
And
my wife claims that I originated from an extraterrestrial origin, but that's a separate matter. We can talk about it later.
as you came flying in from with one of those
Oh,
a stork, but a
well,
stork from
no,
space.
she says when they come to pick you up, at least 10 years ago, she said, just make sure to do two things. One is to leave the car keys with me. And second, please ask them not to ruin the lawn in our backyard when they lift off. But I
Oh,
actually
that's
checked with her recently, and she said that this time she said that she would just ask me to turn off the lights and she will join me. And you
that's
can look
good.
at it in two ways. One is that our marriage is getting better and better over time, that she really will miss me. And the second is that she's disappointed with the way the world turns out to be.
Maybe she doesn't believe in that good Earth, but yeah, it is interesting because you think about. I think it's a great point around artificial intelligence and how they yeah, just and I love this frame of AI as a mirror instead of a crystal ball. And so if we make it a mirror of society, we have to, if we can create a better mirror there, then it can be a better thing. And so
Well,
if we inject it with better things, then it will learn that.
in Genesis, the Old Testament, it said that God created the humans in its image, and we are creating AI in our image. Now, there is this imitation game that was conceived 90 years ago by Alan Turing. That's the Turing test. And we're getting there. We're getting to the point where AI systems will be indistinguishable from humans when you converse with them. Um, and I don't really care about whether they're really similar to humans or not, as long as they are indistinguishable as far as most humans are concerned. You can develop a relationship with an AI system. You can reproduce dead people if the system was trained on those narratives. If both my parents passed away, and if I had an AI system that would be trained on the phone conversations I had every day with my mother, and the AI system was GPT-5, then I think I would have still continued to enjoy the conversations now. So, um,
And would you want that? Do you want that? Like, does that scare you? Or are you excited by that?
no, I would want that. But the point is that so we are creating them in our image, but that's not necessarily the pinnacle of creation. I mean, I don't see the humans at the current state as the most satisfying form of existence. And what I think may happen is, we have exponential growth here on Earth right now in terms of our technologies. And most stars formed billions of years before the sun. Okay, so um, another civilization could have preceded us by a billion years or more, and it takes less than a billion years to traverse the entire Milky Way galaxy, disk of the Milky Way galaxy, with chemical rockets, the type that we launch into space, like Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, or New Horizon, that are making their way to interstellar space. So we just sent them over the past 50 years, but if you wait a billion years, they will traverse the entire Milky Way galaxy. So my point is, there was plenty of time for probes with artificial intelligence to reach us. And if we ever encounter such a thing, then we can let our own AI systems imitate their AI systems, which will be much more advanced. So this will be a twist on Turing's imitation game, in the sense that our AI systems will try to imitate extraterrestrial AI systems, and we could learn a lot from them.
Oh yeah, yeah. I mean, you can imagine just a bunch of these von Neumann probes, these little self-replicating probes going out there into the
Well,
space. Yeah,
I just established a new company together with Dr. Frank Lauke, and it's called the Copernicus Space Corporation, where we are planning to launch a lot of small probes to space and to open up a new frontier, but potentially go beyond the solar system. And so it's not a matter of imagining these things, as John von Neumann did 70 years ago. We're actually trying to do it now.
yeah. That's 70 years ago. It's like, cut it. We got to get our shit together. It's like the
Oh
time is
yeah,
now to make
I
these
mean,
things. Yeah.
that's the whole point, that people keep talking about ideas and having an opinion. But the point is, it's easy to have an opinion. It's also a lazy approach to things. You just have an opinion and you move on. Okay, you have your dinner, you know, and so forth. You just have an opinion. That's it. You move on. But the actual hard work is to make it happen. That's one aspect of it. So AI, now is at last testing Turing's ideas 90 years later. And in the same vein, trying to find objects from extraterrestrial civilizations is something that was mentioned in passing. And for example, Enrico Fermi had lunch 70 years ago, and that people keep going back to that, had lunch at Los Alamos and said, "Where is everybody?" And if you just think about it, if you are single and you stay at home and you say, "Where is everybody? I don't have a partner. I'm unique, special. I'm really the smartest. There is nobody compatible for me." Obviously, you will stay single. The way to find a partner and to learn from the partner is to go out and go to dating sites. And if you want to see your neighbors, you have to look through your windows. If you want to find anything from your neighbors, you go out to the backyard and you check if everything is rocks, because every now and then you might see a tennis ball that was thrown by a neighbor. Okay, so that's very simple, but Enrico Fermi didn't do that. He just said, "Where is everybody?" It's very easy to have an opinion. And then nowadays, what people say, extraordinary claims require extraordinary evidence. That's what Carl Sagan said in the 70s. And that's a devastating statement, because what it says is, let's maintain our ignorance. In other words, let's not seek evidence on things that we regard as extraordinary. Let's allow them to fall into our lap. But the fact that they're extraordinary means that they will not fall into your lap. The conventional things like seeing birds in the sky were seen for decades. They are not extraordinary, and we know that they are there. But if you regard something as extraordinary, you may need to make an effort to find it. So if you don't seek the evidence, you will never find it. So just to give you an example, when I started doing physics, that was, let's see, it was about 50 years ago, 40, 45 years ago. Back then, there was a new symmetry of nature that was advocated. It's called supersymmetry, where every particle has a partner. And then the Large Hadron Collider was funded at $10 billion to smash protons at very high energies and find particles that belong to that symmetry, supersymmetry. Okay, we've done the experiment, $10 billion. We didn't find it. Okay, nobody said supersymmetry is an extraordinary claim, and we need extraordinary evidence. Therefore, let's not talk about it. Let's not do it. Nobody said that, because that's the way the frontiers of science are pushed forward. You test ideas. Some of them turn out to be wrong. Some of them, end up being successful. So, if you want to find extraordinary evidence, what you should say is, extraordinary evidence requires extraordinary funding. I am seeking the evidence. I want to seek the evidence. I want to put the time into searching. I don't just want to have an opinion. Where is everybody? I want to look for everybody. I want to do something about it. Rather than staying at home, I want to find a partner. If I want to do that, it costs effort. It costs money. We have to put the money. But instead, what people are saying, "Oh, it's an extraordinary claim that there are extraterrestrials." Why is that so convenient to say there is nobody out there? Because then we have no competition. Then we are the smartest that ever existed since the Big Bang. Albert Einstein can be celebrated as the most brilliant scientist who ever existed for the last 13.8 billion years. If we were to search and find that there was another scientist on a planet near another star that was much smarter than, or in fact, an AI system that is far better than us, we would feel bad about it. It's just like realizing that we are not at the center of the universe. Obviously, people wanted us to be at the center of the universe, and they put Galileo in house arrest, didn't want people to listen to him. Today, they would have canceled him on social media. It satisfies a very urgent need for us to feel arrogant about our special privilege as being the smartest. And we don't even allow other animals within, on Earth to have sentience. We just say we are the only species. Okay, well, on Earth, maybe you can make the case. I don't know about octopi and so octopus, and but at any event, out there are billions of stars. Okay, tens of billions of planets in our Milky Way galaxy with conditions similar to those on Earth based on the latest statistics that we know about planets around stars. And so I would say it's very arrogant of us to think that we are unique and special and the only ones. And
Yeah.
nevertheless,
So what? Let me ask you a question then. So, and I agree with a lot of this. I mean, I think it's there's I love the idea of like there's a yeah, if Albert Einstein's the smartest person that ever lived in the universe is messed up. Like that's like we gotta keep our bar higher. It's like these AIs are just, we hope to find things that are smarter than that, and it makes me think too of like our fears. So much of this is based off like our fears of death, our fears of public speaking, our fears of there's a deep fear of being alone in the universe, but there's also a maybe deeper fear of being with people
well,
in the universe.
I would argue that being fearful is completely irrelevant. So, first of all,
Well,
Epicurus said that he's not fearful of death because when death arrives, he will not be around. When he is around, death is not around. So, he will never meet death. Therefore, how can you be fearful of something you will never meet? So Epicurus was never fearful of death. But okay, even if you're fearful of the fact that your life will end one day, first of all, it may not be true because we're at some point we will understand how to fix the human body, and it may happen in our lifetime. It's just like a machine; you just have to repair it. Just like taking your car to a place that will maintain it. And we can, in principle, repair the human body and maintain longevity or supplement the human body with things. Just think about Stephen Hawking. He couldn't really move a muscle, and he lived for 70 years.
yeah, and I agree that death is irrelevant to like what the true statement of the thing is, but I guess it's part of like our as humans we're kind of it's part of how we
No,
navigate through the world
it's
and what
part
things
of
we
the
search for
path.
evidence for and what we don't search
But
for. So what do you think? Let me ask you a question. Talk about one of these you talked about doing, and I love that agency energy that you have of just like, hey, we're actually trying to find this stuff out. And so tell us about either this the group that's putting these like rockets into space. You're going to on this trip to like not Puerto Rico, but somewhere random in the world. Like, tell us about like what these searching things are looking like for you and how you're trying to find this evidence.
oh, yeah. So as I said before, I'm intrigued by the possibility that we might have objects from extraterrestrial technological civilizations near Earth. And the reason I started working on that, previously I worked on black holes, on the first stars in the universe. And um, the reason was that in October 2017, the first object from outside the solar system was spotted by a telescope in Hawaii. It was given the name Oumuamua, which means a scout in the Hawaiian language. And it looked very weird. It didn't look like the rocks we had seen before from the solar system. It had a very unusual shape, a flat shape, and at least 10 times longer than it is wide. And moreover, it was pushed away from the sun by some non-gravitational force and didn't show any cometary tail. So it wasn't a comet. We didn't see any gas around it, and it wasn't an asteroid because there was propulsion, there was something pushing it. So it was not just a bare rock. And I suggested that it may be artificial in origin, maybe a very thin film or membrane that is pushed by reflecting sunlight. That was my suggestion, and it was the size of a football field. And then, together with my student Tamir Siraj, we discovered two other objects that came before it. One 4 years earlier, in January 8th, 2014, it was an object that collided with Earth, roughly half a meter in size, slightly bigger than a giant watermelon. And it became a meteor as it burned up in the lower atmosphere of the Earth. And the US government detected it near Papua New Guinea. And from the data that the US government released, we were able to infer that it was tougher than all space rocks that were documented by NASA, 272 of them in the same catalog. So it's tougher than an iron meteorite because it was able to maintain its integrity down to the lower atmosphere of the Earth and was moving really fast. So the question is fundamentally whether it came from some unusual astrophysical source or that is different from the solar system because we haven't seen rocks like that in the solar system, or maybe it's a spacecraft, an artificial object. And we are going to find out. we're going on an expedition this summer to the Pacific Ocean, and I will keep a diary on medium.com. If you just put Avi Loeb, Loeb, first name Avi, medium.
I'll put a link in the notes as well
Uh,
for listeners here.
I will. I regularly have essays every few days there, and I will keep a diary during the summer of my trip to the Pacific Ocean to retrieve the fragments from this meteor. We want to find the composition, and from that we can infer whether it was natural or artificial. Maybe it was made of stainless steel. Just think of Voyager colliding with an exoplanet, and it would appear as a meteor with a very tough composition. So that's my approach, and I established the Galileo project, which has really three branches. One of them is to find more objects like Oumuamua that I mentioned at the beginning, that pass near the Earth, and we see them through the reflection of sunlight. And now we have the Webb telescope, we have the Vera Rubin Observatory that will help us find more of the same and learn about them. So I see the Vera Rubin Observatory that monitors the sky every 4 nights, every 4 days, with a 3.2 billion pixel camera. I see that as a dating app to date the next Oumuamua. And so that's part of it, identifying interstellar objects that way. And also going after the second branch is going after the after interstellar meteors that are found completely differently because they create a fireball in the Earth's atmosphere, just like the one that we are going after this summer. And the third branch of the Galileo project is building observatories, completely new observatories that would monitor the sky 24/7 in the infrared, optical, radio, and audio, and try to figure out the nature of those unidentified aerial phenomena that the US government talks about. And there is a new office under the Department of Defense, the Director of National Intelligence, that is looking at all past reports on unidentified aerial phenomena. And what we are trying to do is not look at the past reports, trying to figure out, because they were anecdotal, the data was incomplete. What I've seen publicly is always fuzzy and unclear. Instead, the sky is not classified, so we will take our own data. And once we have several tens of these observatories in many locations, we will get orders of magnitude more data than was ever reported in the past. And it will be of high quality because we have full control over the instruments and we understand, we calibrate them. And then we use machine learning and artificial intelligence to analyze that data and figure out whether we are looking at a natural object like a bird, or we are looking at a human-made object like a balloon, or perhaps it's extraterrestrial. That would be the main question. Is there anything out there? It's obviously a mixed bag. You have all kinds of objects, but the question is whether any of them could be extraterrestrial. So that's the
Yeah.
third branch of the Galileo project, and it involves many dozens of people in the research team, and we are now getting to the point where we're starting to analyze data. And the first batch of papers, 9 of them will come out very very soon, next week actually, publicly, so you could see the design of the observatory that we have and so forth. And then we will be working after that on the next batch of papers that includes the initial data that we get through our sensors, including what we might find in the expedition.
Yeah, that's amazing. It's a great, it's like, and it makes me think of this great frame on like planetary scale computation where we have a bunch of satellites that are looking at Earth, so that we understand climate change and crops and all this stuff. And so what you're doing now is saying, hey, let's do that planetary scale computation, but let's point it outwards, where we can, instead of having just a couple observatories, let's have dozens of observatories that are getting really good data about the sky every
Well,
night, and then
actually, we also have a contract with Planet Labs that operates
yeah,
hundreds of satellites looking down. Instead of looking at crops, we are looking at objects that are not airplanes. Okay, so we are looking at unidentified objects from both below and above, and we are analyzing. We are now developing the software that uses machine learning to analyze those images from Planet Lab satellites. That this was never done before. As you say, well, people were interested in crops, people were interested in other commercial purposes, and nobody looked at objects that might be unusual that way, except perhaps the US government, which is monitoring obviously the Earth's atmosphere, looking for ballistic missiles. So they may have noticed
Yeah,
something, but all of that data is classified. And
yeah,
I'm not interested in pressing on the US government to release data because it's not a scientific organization, and also, I don't want them to compromise any information about the sensors that are classified. And as a result, we should do the work ourselves. And once again, there are lots of people that dedicate a lot of time and attention to waiting for the government to release information. And I say, well, why waste your time? Why not gather the information ourselves?
yes, that's great. And so thinking about, and as I think about these objects out there, it's kind of an interesting, and back to that initial equation and how you think about aliens and space and stuff. So there are these objects that are coming in, and I guess we'll mostly just learn what I mean, 2017 is pretty recent for us to actually have seen one of these objects, and for you guys to go out there. It makes me think of the original Charles Darwin expeditions, where he's going to these going to the Galapagos or whatever, and is writing these journals. And so we'll be able to see on medium.com. It's like, okay, is Avi, what are you finding? That'd be
Except,
exciting.
we are used to what happens here on Earth. I mean, obviously, Darwin was trying to figure out how life evolved on Earth. What I'm talking about is not the state of Earth, it's the state of the universe, which is a much bigger, we are preoccupied with the two-dimensional surface of this rock that we live on, and all the news is dedicated to that. And when the president of the United States gives the State of the Union address, it's the State of the Union, which is a small part of this surface of the Earth. Okay, that's pretty much what we are focused on. But I think it would make sense for, if we find extraterrestrial life, for the president of the United States to also make a statement about the state of the universe, not just the union. And because it will change our future. If we figure out a smarter student exists in our class of intelligent civilizations within the Milky Way galaxy, we can learn from that student. We can acquire some inspiration. Instead of, right now, we are dedicating $2 trillion a year to military budgets worldwide. And I did the calculation that if we were to allocate that to space exploration, but we could send a CubeSat, a probe, to every star in the Milky Way galaxy within this century. Within this century, just instead of wasting money on killing each other or protecting ourselves against others killing us, if we were to say, okay, forget about this nonsense, let's just explore space, we could send a probe to every star. So if there is, within this century, so if there is another civilization that for some reason paid attention to the words of the song of John Lennon, imagine all the people living in peace. Okay, so they imagine themselves being in peace and follow that. And then, they would be the fittest to survive long term, because they would send what they find precious on their planet elsewhere. They would not just keep fighting on a piece of territory in a zero-sum game war, which is pretty much what's happening in Ukraine right now. And science, really, if you think about science, it's an infinite sum game, because the more you learn about reality, the more you benefit. Everyone benefits. So there is no limit to scientific knowledge, and the reason we need to learn about reality is in order to adapt to it. If we continue to believe that the Earth is the center of the universe, we would never be able to reach destinations in space, to reach Mars, to reach the moon. We would never be able to do that, because we would think that the sun moves around the Earth, and we would send a rocket, it will go in the wrong direction.
Yeah, it's funny because so tell me about this, because I think you have a pretty and I'm generally an optimist as well, but like, are you scared of, so I think about these species out, or these other alien life forms out there. Are you worried that, like, okay, Avi's doing his thing and you tried really hard to find these other things, and then you found some, but you kind of found them too soon or whatever, and they ended up like killing us? Or like, does that worry you, or you mostly think that you're going to find peaceful?
Actually,
how do you think about
a couple of weeks ago, and that's the subject of one of my essays on medium.com, A couple of weeks ago, I gave the last class before the summer at Harvard, and I asked my students. I said, "Well, I'm going to the Pacific Ocean to find the relics of the first interstellar meteor, and imagine that it was a technological object, and imagine that something survived, and I'll find a gadget, at the bottom of the ocean, and suppose it has buttons." So I asked each and every student in the class, "Would you press a button on an extraterrestrial gadget?" And half of them said, "No, we are worried of what it may cause." And I asked them, "Are you worried about your own body, or are you worried about humanity?" And they said both. And then the second half of the students said, "Of course, we want to see what happens if we press a button. It could be GPT 100, and who knows what it may do." And then one of the students asked me, "And what would you do?" And I said, "Well, I regard it just like a traumatized, intelligent animal that you find in the wild, and you bring it to a safe place. And first of all, you don't engage with its body. You just try to figure out what it has. And so I will study it first in the laboratory before I do anything. I will not press a button until I get a sense of what this is all about." But one thing I did promise to the curator of the Museum of Modern Art in New York City, that if it looks like an innocent object, then I'll bring it for display in New York City when we find it, because it will represent modernity for us, and it's also art. It's art of the future.
Yes, I like that. And let me double check on that one other time though, because I think there's a I guess what do you think about this there's this SETI, search for extraterrestrial
Yeah.
intelligence, and there's whether we take stuff in or whether we push stuff out into the world. Do you think that we should be like putting out, talking about dating, we should probably put our dating app out there, and we should probably be putting radio waves out there and saying, hey, we're ready to date, or do you think that we should not do that?
First, keep in mind we have been transmitting for about a century, and there are only about a few hundred sun-like stars within the volume that our signals traversed over the past century. Okay, so not many sun-like stars out of all of the sun, the tens of billions of them in the Milky Way galaxy. So we haven't heard back yet because the signal didn't reach very far. It may reach far enough in thousands of years from now, and then we'll hear back. But so the fact that we haven't heard back is still not saying much. But I'm not particularly worried, because I think that the more advanced civilizations are so much ahead of us. The situation is similar to a biker, noticing a colony of ants in the cracks of the pavement as it passes by. I mean, the biker would not pay much attention to that colony of. So, frankly, I don't think we pose a threat to them, or they just laugh at us. They regard us as a little bit better than nature, maybe, but just like natural evolution of things, but not really a threat. And I disagree with the view that, for example, Stephen Hawking expressed of us, being careful. And he actually visited my home just 7 years ago, and so I think we should explore. I don't think we should engage if we find something, because we need to figure out what this, if it's a functional gadget, what is it seeking, what are its capabilities, what is it doing, and so forth. That would be the smart thing to do, because if you find a visitor in your backyard, your response should be dictated by the qualities of the visitor. I mean, you can't establish a committee now that talks about potential encounters and what to do about them. Some people want to do that. I say it's a waste of time, because our imagination is limited to what we experienced. We look at the mirror and we imagine something like us. But I say, well, we can't really imagine, just like a cave dweller cannot imagine what a cell phone is, because that represents technology so much superior to what the cave dweller is used to. And so when we encounter something near us, it means that civilization was far more advanced than we are, because they reached us. We didn't reach
Yes.
them. They came to our. So the point is that we might not figure out exactly what it means at first, but it would look different than natural objects, than objects that we produced. And I don't think we should be worried about it, because it would very likely be much more superior. It's an opportunity for us to learn because we can import some of these technologies and make a lot of money out of them.
Yeah, yeah, yeah. I think it's a, I can imagine disagreeing with your frame, but I think it's a powerful one, which is just like this constant mindset. And I think it's back, it's like, hey, of learning and trying to understand, what is happening out there in the world, and then all out there in the universe rather, and then also this frame of like, and if there is stuff more powerful than us, it doesn't care, And so I think that we can be this kind of
Yeah.
lesser being,
There is
just trying to learn, kind of like a younger brother or whatever.
no, not a brother. I would say this is an
An
opportunity.
ant, an ant.
No, this is an opportunity to unify religion and science because in religion you find discussions of God, and God represents an entity that is far superior to humans, that, for example, could have created the universe and could have created life. Okay? And I say, we are getting to a point where we might create life in our laboratories, and definitely a more advanced civilization could have created life. Okay, and if they understand how to unify quantum mechanics and gravity, they might have quantum gravity engineers that create baby universes in their laboratories. So if they're able to do that, I would argue that an advanced technological civilization is a good approximation to God. Now you would say, okay, so what's the point here? The point is, I'm talking about something in reality. I'm not talking about stories or miracles that you imagine or read in text. I'm talking about looking at the sky and seeing a miracle. Okay, so just think about the burning bush that is mentioned in the Old Testament, that Moses saw a bush that was burning and was never consumed. Okay, so I say, suppose I bring the Galileo project observatory close to that bush. Suppose Moses had access to our infrared instruments, okay? So then he could have measured the temperature of the bush from a distance based on the spectrum of the infrared detectors. He could have measured the distance of the bush by triangulation and could have inferred how much power is emitted. And based on scientific analysis, it would have been possible to decide whether the bush is just a natural phenomena, that, just like a real bush that is burning and just has more stuff in it, or something else. Okay, so the point is, when you say a miracle is something you don't fully understand, and it could represent that a technological advance that we were never able to produce ourselves. Just go back more than a century ago, we couldn't fly. Okay, so, and we couldn't have nuclear fusion, and so there are lots of things that we learned over the past century, and for us would have been miracles if we were to encounter them. So if you have another civilization that had another century or 1,000 years or 1,000,000 years or 1,000,000,000 years, it would look to us like a miracle. All I'm saying is that religion could, in principle, be unified with our perception of reality because we would see things that appear to us as way above what we can accomplish. And in the past, it was related to God. Okay, it was related to miracles in the religious text. So, and this could be the product of science. I'm saying scientifically you could tell that. So think about
Yeah.
it. It's not a matter of belief. Right now you have people believing in things. I'm saying, suppose scientific data shows you evidence that is beyond any reasonable doubt of an object that has screws and bolts on it and does crazy stuff. Okay,
Yes.
so then you know that it's real.
Yes. Yes. I love that. And let me ask you a question about what you imagine these other species to be like, these, extraterrestrial. Like, do you think, are they carbon based? Are they silicon based? Do they have bilateral symmetry? What is there? Do they have some kind of net based thing that allows them to kind of move, like a neural net kind of thing that allows them to move through their environment and understand it? Like, how do you think about or conceptualize of these alien biologies?
Well, the best I can do is take our current situation and extrapolate to the future, okay? Because I think this will give us a glimpse at our future if they had an extra century or two or more. And the way I see it is that our future will be shaped by AI systems, GPT-N with N bigger than 4. And already now, the number of connections, number of parameters in GPT-4 is not much smaller. It's just within a factor of 6 from the number of synapses in the human brain, 600 trillion. And so, in the coming years, we will have systems that have more connections to the human brain. So I can imagine sending out AI astronauts to space rather than humans, because the human body would not survive very long. If you send a gadget with artificial intelligence, it has the patience to survive for millions of years of travel, and you can harden it. So if I were to imagine what we might encounter, I would argue it would be a technological gadget, if it's functioning, technological gadget with artificial intelligence, not a biological creature, because that's not suitable for space travel over millions of years. And in a way, it will be a glimpse at our own future. So it will serve the important purpose of inspiring us to imagine, what we might become. And so I don't at all think about, what you see depicted in science fiction stories. And the reason is simple. All of those science fiction stories were shaped decades ago, before AI reached the level that it has now. And so, the future is really different. Human imagination is much more limited than reality. That's my basic point. And I never liked science fiction, because it often violates the laws of physics as we know them. I like science and I enjoy fiction. And I think that science can basically uncover, reveal, um, what happens really in out there, what happened before us. Because we just came, Homo sapiens just came over the past few million years, and that's one part in 10,000 of the age of the universe. And we know the universe is not centered on us. So if you arrive to a play, a cosmic play, at the end of the play, and you're not at the center of the stage, it's really straightforward. I mean, the play is not about you.
Yeah. It's amazing to yeah. I mean, the science fiction pieces where we have you like to use science to uncover things that feel like fiction, but in fact are different. And I think that I like what you're talking about with the AI thing, where it's like we're gonna get these little gadgets and it will help us. It makes me think of things where you can see, and in the best form, science fiction does this. So I'm thinking about there's the book about the thing that ended up looking like Wikipedia, or I think about people that do psychedelics and how it helps them like get into better meditative states, where you point at a future in front of you and you say, look, that's actually what I'm going towards. And so if we actually are able to see these gadgets, and we'll be like, oh, great, that is kind of a thing that we can point at in a direction we want to
I
point
mean,
at.
speaking about psychedelics, I would argue that, one solution to Fermi's paradox would be to say that there is this tendency of civilizations to take recreational drugs or put goggles on their head and live in the metaverse. The danger of doing that is that you lose contact with the actual reality. You just live in some imaginary reality where you are next to celebrities and you have a house that is worth millions of dollars because you put these goggles on your head or because you took some drugs, and you can feel very good about yourself, but it's not the reality that we all share. Okay, so if you imagine another species that is, they takes drugs or puts goggles on their head, they will never be engaged with the actual reality. They will eventually perish on their planet because they don't adapt to changing circumstances. Eventually the climate will change or the star will burn up the surface. They will die with the goggles on their head. You can go there and find their archaeological relics, but they will not survive very long because they are not engaged with the reality. Okay, so that's really what science is about. It's not about dreaming about extra dimensions. It's not about dreaming about the multiverse, things that we can't really experience through experiments. Science is about collecting data, collecting evidence about the reality that we all share and learning from it. And even scientists do not understand that. The fact that people talk about extra dimension in theoretical physics for half a century now, where there is no hope to even detect them because we haven't seen any evidence for that. That's a little bit crazy, right? To talk about a concept that we have no evidence for, that there might not be any evidence for, as part of the mainstream of theoretical physics for 5 decades. Like, how can that happen? And at the same time, ridiculing the possibility that there might be equipment coming close to Earth from other civilizations, even though we ourselves, we sent 5 probes to interstellar space. We know that planets are abundant. There are billions of them in the Milky Way galaxy, like the Earth. And we know that most stars from billions of years before the sun, you just add these facts and you say, okay, well, it makes complete sense for us to search for that. And then you ask the public, do you care about this question? And they would say, of course, that's the most important question. And then you look at the scientific community saying, oh, we don't want to take risks because we might be wasting taxpayers' money. Well, go out and ask the taxpayers what they care about. And you will learn that they care about whether we have other civilizations out there more than whether we have extra dimensions. They care about it more, and you don't fund this kind of a search. So that's the place where I find myself in. This should be a subject that belongs to the mainstream. It makes complete common sense, right? And
Yes,
I
yeah.
find that common sense is not common.
It's true. It's true. There's a lot, and people get pushed into these little intellectual niches, and
Well,
the publisher parents
there
and
is a
everything.
very
So,
simple reason for that. If you look at, for example, at gymnastics, you say, okay, well, people that do gymnastics, it doesn't really serve any practical purpose. Why do they do gymnastics? And the answer is they want to demonstrate, their qualities as athletes, that they are able to do all these maneuvers and so forth. And, I would argue that it's intellectual gymnastics, it's mathematical gymnastics. What happens in academia very often, people just want to show off that they are smart. They don't care what reality is. In fact, it's even better not to have experimental verification, because then you might be proven wrong. So go to a niche where you're not tested experimentally, because then you can keep doing it forever and just demonstrate that you're smart by doing all these mathematical gymnastics. And as long as a big enough community agrees to that, just like a big enough community of athletes agrees to do gymnastics, it's being practiced as part of the completely reasonable thing to do. However, I say that it betrays the purpose of the profession, because in the context of physics, you can do it as part of mathematics. That's perfectly fine. You can show off in terms of your intellectual abilities by doing mathematics. That's perfectly fine. But you can't call yourself a physicist, okay? Unless you are exploring reality. And what that means is that you need to have some friction with experimental tests. And, it's just like a plumber that comes to your home and you say, can you fix the toilet for me? And the plumber says, it's too difficult. And then you say, well, can you fix this pipe over there for me? And he says, no, it's too difficult as well. But you know what? If you put goggles on your head and you live in the metaverse, there, I'm fixing everything. So I argue, if you say, okay, you ask a string theorist, you say, can you tell me what happened before the Big Bang? That was a singularity of the theory of general relativity. Okay, so what happened? They say, well, it's too difficult. We are supposed to unify quantum mechanics and gravity. That's our profession, but it's too difficult. Then you say, okay, I'll give you a simpler problem. What happens inside a black hole? We know that black holes exist. We have an image of one, which, by the way, was obtained at the Black Hole Initiative that I founded at Harvard. So you ask them, what happens inside a black hole? And they would say, it's too difficult. We can't do that. But if you believe in extra dimensions, in other words, if you put these goggles on your head, then there I might be able to. So my point is, I wouldn't give my money to such a plumber, because it betrays the rules of the profession. Is all about solving real problems in the real world that we all share.
Yep, I like that. Let me ask you a general question here about your orientation, and as we're in like the final 10 minutes here or so, tell me about how you work. Tyler Cowen calls this your production function. You wake up, you're writing books, you're teaching, you're going to Papua New Guinea. Tell us about like how you make these and you're finding black holes. How do you work? What's your production function?
So it's really simple. If you want to have a simple model of me, just think about a farm boy. Okay, I was born on a farm. I'm very simple-minded. What you see is what you get. I'm not manipulating people. I'm very transparent, so to speak. So I'm attached to nature. I was born on a farm. I'm still attached to nature. So what happens to me when I wake up, I usually check my email. And then within half an hour, usually I wake up at between 4 and 5 a.m. And then I go to a jog at sunrise. When the sun rises, I go out and jog for half an hour, about 3 miles. I can, in principle, if I was racing it, I could do it at half the time, but I just do it more leisurely. So for half an hour, I jog 3 miles at sunrise. And every day it's different. The weather is different. I jog every day, independent of whether it snows, rains, whatever. because it's all part of nature, and I enjoy feeling it. Even if I get home completely wet, I don't care about it. And then I come back at around 6:30 a.m. and I have my breakfast and I move on to write creative work most of the time. Now, this was not true a decade ago. I was at the time, for 9 years, between 2011 and 2020, I was chair of the astronomy department at Harvard. I was the director of the Institute for Theory and Computation at the same time. And I was the founding director of the Black Hole Initiative, which studies black holes at the same time. And I chaired the board on physics and astronomy of the National Academies at the same time. And I also chaired the Starshot initiative at the same time. And I had, on average, between 5 and 10 students every year that I had to mentor, and I was teaching a class. Okay, so all of these consumed my time, and people would knock on my door, interrupt my train of thought. I couldn't really dedicate a block of time to creative work. Now, the miracle happened when the pandemic started. So suddenly nobody knocks on my door. I have the time for myself. Then I started jogging. And I also finished 3 terms of being department chair. So that was 2020, and I could then have more time for creative work. So as a result, right now I'm mostly doing creative work. So I write essays every couple of days or 3 days in medium.com, and I wrote the new book Interstellar that is appearing in August 2023. I also am leading the Galileo project and writing papers. I just had 3 scientific papers over the past 2 days posted on the archive. So I work with young people. So the point is, I have ideas and they bubble up. It's not a matter of effort. When someone comes to speak with me, I immediately have something interesting to say about what they are doing, and very often it results in a paper. Okay, so that's a fact. You can speak with dozens of people that worked with me, that were mentored by me. I had maybe 50 to 100 students and postdocs working, postdocs maybe hundreds, okay, and that worked with me, and they will all tell you the same story, that they came to my office, mentioned something, and I came up with an idea and we ended up collaborating on it. That's a very standard routine, and it just comes to me naturally. It's not a major effort to come up with ideas. What surprises me is that these ideas are not evident to the people who speak with me. They think it's a great thing that I came up with the idea. When I started astrophysics, it was really interesting. The first mentor I had was at Princeton, and for a postdoc fellowship, John Bakar, and he asked me, how many computer languages do I know? And I said, I don't use much the computer. I just use it whenever I have a set of ordinary differential equations to solve. I use it as much as needed, but I try to avoid it. And he said, how can you imagine having a scientific career without mastering computer languages? And that was 40 years ago, and I managed to have a successful career because for some reason, the ideas that I have are not obvious to other people. I mean, I just don't understand why, because they come to me immediately. It's not as if I think about it for a month and I come up. It's like immediately. So that's my style. And I said to my students and postdocs that if at some point I stop having ideas, well, either I will go to politics at that point, because then I will not have the pressure of actually writing it. The problem is I can't take a vacation, because if I take a little bit of rest, suddenly a dozen of ideas come to my mind. I have to write them up. These essays, I always write an essay on a new subject every few days. It's like not a series of essays that replicate the same thing. So the point is, the ideas come up all the time, and at some point it might stop, at which point I might do some more administration or politics. But I would not find a meaning to my life at that point also. So as far as I'm concerned, they can shoot me at that.
Nice, exactly. We'll put you down behind the shed, and we'll say, hey, because it is amazing though, because I think it makes me think of, like, you were just you were just born and you were kind of nurtured as a generative person, and so yeah, you're a generator, and so you generate, and then you have developed this amazing way to generate in collaboration with others, and so it's awesome to kind of see that and see the results of that. Let me go to a final couple questions. One is what advice do you have for ambitious young people?
So it really depends on whether how creative they want to be. Okay, if they wish to innovate, and here I'm giving advice in academia. I mean, it's different in the commercial world, and I haven't experienced that much, and obviously it's different now than it used to be. But in academia, it's similar to what happened to Pablo Picasso. When Pablo Picasso started, he painted realistic paintings. That in the tradition of the Renaissance, people that were before him. And once he mastered that, only decades later he developed the disruptive style of cubism, which was completely new and people couldn't really understand it at first, but it became eventually very popular. So I argue that you should do the same thing in an academic world, because you need to acquire jobs, like first postdoctoral fellowship after your PhD and then tenure. So that time you can dedicate to following the beaten path and demonstrating that you're good at it. And the reason is simple, because most people are not capable of innovating. Okay, so and they are sitting on these promotion committees. Okay, and if you were to show sparks of innovation that are disruptive, they will get upset because they are not capable of doing that. Okay, it's very simple. People often select those that do not threaten their ego. Okay, so if you want to get promoted, you have to sort of practice academia the way that non-creative senior people do it. Okay, and then once you get tenure, that's the turning point. That's the point where you can do innovative work, and that is disruptive, the way that cubism was to the art world. And
Yeah.
and so that's my advice. It's a practical advice that will allow whoever goes through it, which is pretty much what I did. It would allow you to get to prominent positions and never, and still maintain your creativity. However,
Yeah.
what usually happens is, uh, if a young person has the creative powers, the young person does a little bit of creative work that may be disruptive, and then gets burned up very often quickly, in the sense that there is a lot of friction with people who maintain the conventional paradigm. And then these young people are so burned up, either they give up or they decide not to pursue it anymore, and they learn their lesson and they conform. And after they get tenure, they just wish to get prizes, honors, and awards and likes on social media. So they basically become part of the troops that maintain conformity. And unfortunately, that's the reality that we live in.
Yeah, yeah, that's sad. Sad that you have to play the game to some extent, but then sometimes people get wrapped up into it. So let me ask this final section here about overrated and underrated. So I'm gonna say a thing, and then you'll tell me whether you think it's overrated or underrated, and kind of a one sentence for why. So do you think the James Webb Space Telescope is that overrated or underrated?
I think it's underrated. It has a fantastic capability. The only criticism is that it costs too much money. I mean, it was originally planned. I was on the first committee that designed it, and back in 1995, and back then we were thinking about $500 million, and it ended up costing $10 billion. That was the only issue, and it was delayed. Also, that's the other problem with it. But it ended up being an amazing telescope. So I have no. I mean, the only risk that we have with Webb is the micrometeorites that are colliding with it that we have no control over, and that's the only thing to be worried about. But otherwise, it's performing fantastically.
Great. Yeah. So underrated, but a little too expensive. What about SpaceX? Is SpaceX overrated or underrated?
Um, I th- I think it's rated just right. And I think the main innovation there is that it is capable of bringing things to space at a much lower expense. That is not caught up in the bureaucracy of NASA, and NASA is using it. So it's just developing a vehicle that is much lower cost and more effective. So in a way, I salute the success of SpaceX. I think it's a great thing we have. Yeah.
Yeah. Being able to shoot stuff is nice. What about the size of the universe? Is that overrated or underrated?
Underrated, because one thing we know is that the conditions that we see in the universe are pretty much uniform, up to one part in 100,000 across the horizon of the universe. And we can tell that there is no edge right next to what we can see. We can see a finite distance that light traveled since the Big Bang. We can't see beyond that. But we know that there is no edge beyond that, because it would distort the region that we can see. And if you convert that to numbers, it turns out that the constraint is that the universe has the same conditions out to a distance that is 4,000 times bigger than the horizon that we can see. Okay, so that means that the size of the region that has the same conditions as we can see is 4,000 times bigger. So there are 4,000 cube times more galaxies, similar to the ones we see with the Webb telescope and so forth, beyond our horizon, that we would never be able to see. So it's underrated, because there are so many. We already know that there are 4,000 cubed, which is like 64 billion more galaxies beyond the region that we can see, that have the same properties as the Milky Way galaxy or other galaxies that we see.
Yeah, it's really, really, really big. Well, beautiful. Well, Avi, thank you so much for coming on the show. For listeners that want to check out Avi stuff, yeah, definitely check out avi.loeb at medium.com. That's Avi AVI dash, hyphen LOEB.medium.com. It's amazing. It's just like a log of exponential history. Is space-time continuous or discrete? Will your home be hit by a meteorite? All kinds of really interesting things there. Also, check out either of his books. There's Extraterrestrial, which again it's in many, many languages, bestseller, etc. Really good way to kind of understand intelligent life beyond Earth. And then Interstellar is coming out in August, so definitely check that out when it comes out. Avi, anything else to say to the listeners today?
Well, stay tuned. The most exciting things are yet to come.
Yeah, exactly. And maybe in 1 year from now or 6 months from now, you'll have this amazing little object that you found from Papua New Guinea, and we'll see it on the internet, and you'll go to the Museum of Modern Art, and you'll click the button, and hopefully it won't kill us all.
No, I will not click it. Don't worry about it. I will not click a button.
Okay.
Thanks so much for listening today. If you liked the show, please give us a 5-star podcast review or subscribe on YouTube. And if you'd like to chat about this episode with a community of amazing, smart, ambitious, divergent people, come on by and join our Discord. You can find it at root.co. That's ROOTE.co. And then finally, if you'd like to contribute to these ideas being shared more widely in society, you can support the podcast production team at patreon.com/Rhys Lindmark. That's patreon.com/RHYSLINDMARK. Thanks, and see you here for the next episode. Bye.